And here we go with the cosine law. What's this one? It's different than the sine law because, well, you'll see it looks more complicated in a sense. It's bigger. It involves squares and multiplication as well as the cosine. Let's see here. When would you use it though? It's if you need a third side of a triangle, and you know two sides and an angle between them. Or if you have all three sides of a triangle and you want to find one angle, that's when you use this. You couldn't use the sine law for those. Any situation where you can use the sine law, use it instead, because the cosine law is usually more difficult. There you go. Sure. Okay. So, by the way, just so you know too, I haven't written this one way, but do you see that? Here, look at this. Always look at the angle A. Okay? So if angle A is here, the number on the other side, the A squared equals, that's always the one opposite there, right? Do you follow what I'm saying there? Okay. Now that's important. The other sides, the B and the C, are the ones right beside the angle. Okay, so the side, then the angle, and then the side when I put that on an angle. Anyways, let's rewrite this as a different way because we should be able to change the letters and it should still be the same formula. So what if I wanted to solve for C squared, for example? Well, how did it work here? When I said I'm solving for A squared, I said the other two sides squared on this side of the equal sign, right? Minus 2 times those sides multiplied. But then the angle has to match the side you're finding. Do you follow how that works? So if we rewrote this as C squared equals, what do we got? Yeah. A, B, B, A, I'll keep it alphabetical. Cosine of side, or side angle, C. Okay, good. Okay, so you see how, like, and if I change the letters to E, F, G, or whatever, it doesn't matter, it's still the same formula. Likewise, I could have changed all the letters around on this too, right? Mind you though, sometimes what I just do, if students find it confusing, is I just relabel a triangle as ABC if it's going to be more difficult if you have E, F, G and stuff. Okay. Now, calculate the length of side A. This is done so that it's right off the bat, you don't even have to think about changing letters. So let's go for it. How do we use this formula basically? Length of side A, well that's directly plugged into A squared, B squared plus C squared minus 2BC cosine of that opposite side A, or the angle opposite the side. Now, it's just a matter of plugging in your numbers. A happens to be what we want here. So A squared equals, and you throw in your 5.2 squared, 7.9 squared, minus 2 times 5.2 times, sorry, 7.9. Now, do you notice I was just doing this and I noticed something here? You might notice that I actually put my B and C in backwards. I put my 7.9 second. That doesn't matter though, okay? Like as far as this and as far as this, okay? Now, this is all a big calculator thingy. You should be able to do it in maybe 2 or 3 chunks with your calculator, but I'll write out the full answers right now. And you should be able to get it down to just basically 2 steps on the calculator. But first you'd say 5.2 squared. Whether you choose to write it out or not, 6.241 plus. Oh, what am I doing here? Sorry, I've changed the order again. Oh, God. Hey, okay, 27.04 plus 62.41 minus 2 times the 5.2, the 7.9 is 82.6. Good, thank you. And then the cosine of 43, hit it and get a decimal number, point. Then you could just toss it all together using plus and minus stuff I've got. I'll just do it in 2 chunks. 89.45 minus 60.6. Subtract that, you got a squared equals 29.39. The whole time you're doing this, so don't forget you got this as a squared. The next thing you do is the square root, yes. So that's what I was going to say. Remember, you have a square there, so you're not done yet. So what you need to do is undo the square. And there you go, 5.4. And it's centimeters. Is it good? Good. How about if you were asked to solve the angle? Nope, that's fine. Did you remember that I had another formula, and I'll give this kind of thing on a test. This way, right? The cosine formula equals. So that's the one you probably want to use if you're solving for an angle. So I'll use it this way. Should we write it in terms of p's and stuff, or should we just go with, well, here's the formula. Cosine of A equals b squared plus c squared minus a squared all over 2bc. Now that's the given formula that you'll have on the test. We want the size of Q. Oh, I didn't mean to do that. Q. This angle. So that's like our cos of A, right? So why don't we put it down as cosine of the Q angle. Now, if this is like our A, we could call either one of these B and C. It doesn't really matter. This would be like our B. This would be like our C. This would be like your little, you know, you can imagine that, right? You don't really have to write it out. So the cosine of Q is what we're trying to find. And, well, we got the 31.2 squared. I'll plug them all in. So our little b is like 31.2 squared plus 21.6 minus 16.9 squared. Underneath, the 2 times the BC is 31.2 doubled and 21.6 multiplied in there too. Now, you can work this out on a calculator. Don't ever try to do that one in your head. Well, you can. But when you do this, and I wouldn't write it out as all these full chunks, but you should get 973.44, 466. Now, that's just squaring, and now you can add and subtract. And on the top, adding 973 plus 466 minus 285 with all the decimals included, 1,154.39 over the bottom, 1347.4. When you do that, you haven't really solved the problem yet. This is still a cos of Q equals. And that's actually a decimal number, 0.857, when you divide it out. So how do we go from cosine of Q is equal to 0.856 to the Q angle? Inverse, good stuff. So Q itself is equal to the inverse of cosine, that second function by 0.856. long as you're on degree mode, 31 degrees. Now, you did it, or?
No, I did it.
You didn't? We'll take a look at it. It's a big word problem. There's a bit to it, yeah. Mariah and Raphael are going hiking through a park, fairly level ground. Both leave the same spot in the parking lot. Mariah follows one trail. She walks 4.3 kilometers per hour in one direction, 40 degrees east of the north. Raphael, different trail, 4.8 kilometers per hour and 52 degrees east of south. So, how far apart are they after 2 hours? Do you remember the speed distance formula at all? Not that you have to, if you needed it on a test, I'd tell you. But there's variations of it. On your car, what is speed measured in? Speed limit outside, it's 40. 40 what? Not just kilometers, per hour. That's the distance. Speed is distance over the time. Hello, Tristan. So that's kilometers per hour as an example speed. If we want to just solve for the distance traveled though, and I think you'd know this intuitively, you just want distance, wouldn't you take, I'll tell you one for example. You were traveling at 100 kilometers per hour for 3 hours, how far did you go? 300. You just multiply the speed and the time, right? Okay. So that's what we're going to use first of all. Because you got the two people, how far did they each walk in 2 hours, right? Let's just say that Ryan. Her distance in 2 hours would be speed and the time. Where is it? One trail walking 4.3 kilometers per hour. For 2 hours. How far apart are they in 2 hours? This just gets a start. You notice how there's an H on the top here and an H on the bottom? So it really just doubles that for 8.6 kilometers. What about the other guy, Chuck or Raphael or Leonardo? Him, his distance after 2 hours would be 4.8. Okay. 4.8 kilometers per hour. 2 hours. Thank you, 9.6. That's his distance traveled in 2 hours. Now, all we found now is the distances that they left. Remember they're at a weird angle though? They're not directly across from each other. So let's just draw this here and I'll help you out with this. I'm just drawing this here to say like this is straight up north. Right? This isn't where they've traveled, but which one is which? Mariah and Raphael. She's traveling 40 degrees east of north. Okay, that's Mariah. So, if you can imagine, you know, maybe they both start at this point right there. If she's going 40 degrees east of north, it's something like this. That's 40 degrees over, you know. Okay, so I'm going to grab, and we know that she travels 8.6 kilometers in that time, right? So let's draw a line that represents her 8.6 kilometers. 8.6 kilometers. We know that this angle here is 40 degrees. Right? Now Raphael, let's see, 52 degrees east of the south direction. And he travels 9.6. So 52. 9.6 kilometers. That's 52 degrees. Okay. We got something here now. Because what we want to find is the distance, how far apart are they? So from here to there. We want to find that third line. We only have two sides. We want a third side, but we have no angles. Can you get the middle angle though somehow? Yep. Yeah. So this is 180 minus the 40 and the 92. Then you've got, well, that's practical. I put 88, I added it to my head to make 92 off, and yeah, 52. I was doing the math. It's 88. So this is 88 degrees here. Now we can find, let's call it A, because that's the way the formula is written. It makes it easier to think of. Squared equals, and then you could just throw in your numbers. The B squared plus C squared is the 8.6 and the 9.6 squared. Cosine of 88 in this time. So if you throw in your numbers, and I'll leave you to figure that out, your work should give you an answer of A equals 12.7 kilometers. Okay? So you can work that one out. I'm going to stop the recording then, and I should do a round now that I've got the recording stopped.